Hello students. Students, in previous lecture we discussed uncertainty principle, according to which it is impossible to determine simultaneously the exact position and exact momentum or velocity of moving microscopic particles with absolute accuracy. That means when we measure position and momentum of a moving material particle, there will be some uncertainty. So students, mathematically speaking, it was that if delta x be the uncertainty in measuring position and delta p be the uncertainty in momentum, then product of these two is equal to or greater than h upon 4 pi, or we write it as delta x into m delta v is h upon 4 pi, or we write delta x into delta v is equal to h upon 4 pi m. So these three are the mathematical statements of Heisenberg uncertainty principle. Now also in alternate form it was written as that delta x into delta v can be written as delta E, that is change in uncertainty in energy, into delta t is equal to, t is for time, h upon 4 pi m. So students, these are the mathematical statements of Heisenberg uncertainty principle. Now students, today we are going to discuss what is the significance of Heisenberg uncertainty principle. So students, today's topic is significance of uncertainty principle. So today we are going to discuss significance of uncertainty principle. Now students, one of the most important implication or significance of the Heisenberg uncertainty principle is that it rules out the existence of definite paths or trajectory of the particles such as electrons, protons, etc. So that means किसी भी माइक्रोस्कोपिक पार्टिकल का जो डेफिनेट पाथ या उसकी ट्रेजेक्ट्री का एग्जिस्टेंस ये रूल आउट करता है अनसर्टेनिटी प्रिंसिपल. स्टूडेंट्स, ये कैसे हुआ मैं आपको क्लियर कर दूं. स्टूडेंट्स, किसी भी मूविंग पार्टिकल का अगर आपको फिक्स्ड ट्रेजेक्ट्री फाइंड आउट करना है तो उसका पोजीशन और उसका वेलोसिटी आपको हर मोमेंट पे पता होना चाहिए. दैट मीन्स सपोज अगर एक मूविंग पार्टिकल ऑफ डेफिनेट मास, ठीक है, उसका आपको वेलोसिटी पता है, उसकी आपको लोकेशन पता है, तो किसी दूसरे मोमेंट पे, किसी दूसरे इंस्टेंट पे वो पार्टिकल कहां होगा वो आप बता सकते हैं. दैट मीन्स उसका आप पूरा पाथ ट्रेस कर सकते हैं और ट्रेजेक्ट्री बता सकते हैं. बट स्टूडेंट्स, since we know that it is impossible to determine simultaneously the exact position and exact velocity of a moving particle, therefore the exact trajectory or the definite path of the particle cannot be determined. So this was the first implication of the uncertainty principle. So we say it rules out the existence of definite paths or trajectories trajectories of electrons and similar other particles. So this is a very, very important point. Second important implication of the uncertainty principle is that it rules out the existence of electrons inside the nucleus. Now students, we all know that nucleus के अंदर electron नहीं होता है. But students, mathematically we can prove it with the help of uncertainty principle. How? Students, उसके लिए say अगर इलेक्ट्रॉन से न्यूक्लियस में होगा भी तो उसका जो से अनसर्टेनिटी जो होगा इन पोजिशन वो होगा जितना डायमेंशन है न्यूक्लियस का. से इट इज ऑफ ऑर्डर 10 raised to power -13 मीटर और वी कैन राइट 10 raised to power -15 सेंटीमीटर. से मैं मीटर में लिखता हूं. सो स्टूडेंट्स, अगर डेल्टा एक्स इतना है तो डेल्टा वी कितना होगा अकॉर्डिंग टू अनसर्टेनिटी प्रिंसिपल? इट इज h upon 4 pi m into delta x. Now h is Planck's constant, which is 6.626 into 10 raised to power -34 divided by 4. Pi is 3.14 approximately. Mass of electron is 9.1 into 10 raised to power -31 kg. And uncertainty in position is equal to the dimensions of the nucleus, that is say 10 raised to power -13. Now students, when we solve this, see these 31 and 34, so we are left with what? -3, and then we are left with -10. So we actually have 6.626 upon 4 into 3.14 into 9.1 into 10 raised to power what? 10 meter per second. Now students, this value is greater than, जब आप इसको solve करेंगे you'll find this is greater than the velocity of light, that is 10 raised to 3 into 10 raised to power 8 meter per second. अब students, uncertainty in velocity is greater than the velocity of light, and students we know that this is not possible. ये possible ही नहीं है. So इसका मतलब ये हुआ students, अगर अनसर्टेनिटी इन वेलोसिटी, अगर इलेक्ट्रॉन न्यूक्लियस में होगा, अगर वो पॉसिबल नहीं है तो इट मींस जो मैंने एज्यूम किया था कि इलेक्ट्रॉन अगर न्यूक्लियस में है तो वो हमारा एजम्पशन ही गलत है, बिकॉज दिस वैल्यू इज नॉट पॉसिबल. सो दिस वाज द सेकेंड इंपॉर्टेंट इंप्लीकेशन ऑफ द अनसर्टेनिटी प्रिंसिपल, दैट इलेक्ट्रॉन्स दे कैन नॉट रिजाइड इनसाइड द न्यूक्लियस. नाउ स्टूडेंट्स, the third significance, in fact we say that uncertainty principle has significance only for moving microscopic particles. Now students, in daily life we deal with macroscopic objects. That means in daily life we deal with large sized objects, and therefore we can say that uncertainty principle has no significance in our daily life. So third important point is that it has, uncertainty principle has no significance. It has no significance in our daily life. It is significant only for the what? माइक्रोस्कोपिक पार्टिकल. हमारे डेली लाइफ में हम डील करते हैं स्टूडेंट्स बड़े ऑब्जेक्ट्स के साथ, और उनके लिए इस प्रिंसिपल का कोई सिग्निफिकेंस नहीं है. नाउ लेट्स प्रूव दिस बाय टेकिंग एन एग्जांपल. नाउ स्टूडेंट्स, से इफ आई टेक अ माइक्रोस्कोपिक पार्टिकल से ऑफ मास 1 milligram. Now 1 milligram is 10 raised to power -3 gram, or we can write it as 10 raised to power -6 kg. Say this is the particle that is we are considering. Now students, delta x into delta v for this particle would be what? Delta x into delta p is equal to h upon 4 pi into m. H we know is 6.626 into 10 raised to power -34 joules second. 4 into pi is 3.14 into mass of the particle we are taking 10 raised to power -6. Now students, when we solve this, we get 10 raised to power -28 meter square per सेकेंड. सो अगर स्टूडेंट्स अनसर्टेनिटी प्रिंसिपल को मैं एक मैक्रोस्कोपिक ऑब्जेक्ट के लिए से यूज करता हूं, द अनसर्टेनिटी इन पोजिशन इनटू अनसर्टेनिटी इन वेलोसिटी जो आएगा 10⁻⁻28 आएगा, विच इज व्हाट, विच इज टू स्मॉल. इसका मतलब ये हुआ स्टूडेंट्स, किसी भी बड़े ऑब्जेक्ट में प्रोडक्ट ऑफ अनसर्टेनिटी इन पोजिशन एंड अनसर्टेनिटी इन वेलोसिटी इज टू स्मॉल, वो नेग्लिजिबल है. दैट मीन्स किसी भी बड़े ऑब्जेक्ट का हम साइमल्टेनियसली पोजिशन और वेलोसिटी दैट इज मोमेंटम एक साथ मेजर कर सकते हैं, क्योंकि उनके अनसर्टेनिटीज का जो प्रोडक्ट है इट इज नेग्लिजिबल. सो स्टूडेंट्स, दैट इज व्हाई वी से दैट this principle, that is uncertainty principle, has no significance in our daily life. Now students, one more thing. Now let's apply this for electron. Now say for electron, अगर सपोज यही मैं देखता हूं, इलेक्ट्रॉन का मास आपको पता है, इट इज व्हाट, 9.1 into 10 raised to power. Okay, H is 6.626 into 10 raised to power minus 34, 4 into 3.14, and mass of electron is 9.1 into 10 raised to power minus 31 kg. Now students, when we solve this, we get uncertainty in position into uncertainty in velocity का जो product आएगा, we get it to be what, 10 raised to power minus 4 meters square per second. Now students, this value is what, this value is sufficiently large. इसके comparison में ये बहुत ज्यादा, this is sufficiently large. That means सिर्फ माइक्रोस्कोपिक पार्टिकल के लिए ही अनसर्टेनिटी प्रिंसिपल का सिग्निफिकेंस है, क्योंकि अगर नहीं होता तो ये वैल्यू नेग्लिजिबल आता. बट स्टूडेंट, इसके कंपैरिजन में ये बहुत बड़ा है, ठीक है, 10 raised to power 24 टाइम्स ज्यादा वैल्यू आ रहा है. सो दैट मीन्स देयर इज अनसर्टेनिटी इन लोकेटिंग द पोजिशन एंड मोमेंटम ऑफ व्हाट, इलेक्ट्रॉन व्हेन वी मेजर दीज टू साइमल्टेनियसली. नाउ स्टूडेंट्स, इसका मतलब यह हुआ दैट जो बोहर्स मॉडल में कहा गया था दैट इलेक्ट्रॉन्स आर रिवॉल्विंग अराउंड द न्यूक्लियस इन वेल डिफाइंड पाथ, अब हम कह रहे हैं दैट एग्जैक्ट पाथ ऑफ व्हाट, मूविंग इलेक्ट्रॉन्स कैन नॉट बी व्हाट, डिटरमाइंड. हमने ऑलरेडी रूल आउट कर दिया है दैट किसी भी मूविंग पार्टिकल का एग्जैक्ट ट्रेजेक्टरी या उसका जो डेफिनेट पाथ है हम नहीं बता सकते. So students, इसका मतलब ये हुआ for electrons also which are moving around the nucleus in an atom, ठीक है, we cannot realize that electron एक definite orbit में ही घूम रहा है. Rather students, we talk about probability, means nucleus के around वो वहां हो भी सकता है, नहीं भी हो सकता है, और उसका velocity भी change भी हो सकता है. So students, in modern terms we say that what, there is probability of finding the electron in a definite region, but वहां पर नहीं भी हो सकता है, and even उसका velocity भी fixed नहीं है. And student, this is what happens in quantum mechanics or quantum mechanical model. Even आपको से अगर थोड़ा बहुत आइडिया है that in quantum mechanical model हम ऑर्बिट की बात ही नहीं करते हैं, we talk about orbitals. And what are orbitals? Students, orbitals are region of space around the nucleus where probability of finding the electron is maximum. Students, वो 100% नहीं है. Generally we say it is 90 to 95%. That means 5 to 10% है chances है कि वो वहां नहीं भी हो सकता है. That means हम कह रहे हैं एक probable picture की बात कर रहे हैं. So हम ये realize नहीं कर सकते जैसा कि बोहर्स मॉडल में था that electron क्या है, एक definite orbit में ही घूम रहा है. So students, with this we end our topic, that is uncertainty principle क्या है उसके बारे में मैंने आपको बता दिया. Now students, will discuss some numerical problems based on uncertainty principle. So we have first numerical Now, all these numericals are from competitive exam. So first question says, okay, given mass of electron 9.1 into 10 raised to power minus 31 kg, and Planck's constant is given 6.626 into 10 raised to power minus 34 joules second. Now, the uncertainty involved in the measurement of velocity, आपको निकालना है with an uncertainty of distance, that is uncertainty in position, is 0.1 angstrom. That means it is 0.1 into 10 raised to power minus 10 meter, or we can write it as what, 10 raised to power minus 11 meters. So students, mass of electron is given, Planck's constant is given, uncertainty in distance is given. We have to determine what is the uncertainty in velocity. So let's solve this. And students, we have options also. We have 4 options for this question. The first option is 5.79 into 10 raised to power 8 meter per second. Second option, we have 5.79 into 10 raised to power 5 meter per second. Third option, we have 5.79 into 10 raised to power 6 meter per second. And then we have 5.79 into 10 raised to power 7 meter per second. Now students, let's solve this. We know that according to uncertainty principle, that delta x into m delta v is equal to h upon 4 pi. और students, delta v क्या हो जाएगा, h upon 4 pi m into delta x. Now h we know 6.626 into 10 raised to power minus 34. 4 pi is 3.14. Mass of electron is given 9.1 into 10 raised to power minus 31 kg into delta x, that is 10 raised to power minus 11. Now students, solving this, we get 5.79 into, now this is minus 3, okay, this is minus 8, ऊपर जाएगा, so okay, so ये 10 raised to power, क्योंकि decimal भी आ गया, so we have 10 raised to power 6 meter per second. So correct choice is option C. Now students, let's move to the next question. Now this question was asked in AIEEE as well as in CBSE PMT. Now students, second question is, now this is another very important question. If uncertainty in position, if uncertainty in position and momentum are equal, if uncertainty in position and momentum are equal, then uncertainty in velocity, is, and we have 4 options. First option says 1 upon m root h upon pi. Second option is 1 upon 2m root h upon pi. Third option is only h upon pi. And fourth option is under root h upon 2 pi. So students, this is the question. Now let's solve it. Now students, see, it is given that uncertainty in position and momentum are equal, which means delta x is equal to delta p. So So students, therefore we can write this delta x into delta p is equal to what? H upon 4 pi as what? Because ये दोनों equal हैं, so delta p into delta p, that is delta p square, is equal to h upon 4 pi. So students, from this we write delta p is what? It is equal to h upon 4 pi root, which is what? It is 1 upon 2, 4 का square 2 होता है. This is h upon pi. Now students, this is delta p, so delta p is m delta v. So m delta v is 1 by 2 root h upon pi. So uncertainty in velocity हमें निकालना था, so delta p is therefore 1 by 2 m and h upon pi. So students, option B is the correct answer. Now let's discuss one more numerical. Now in next question, student, it is given that the uncertainty in the position of electron, the uncertainty in the position of electron moving with a velocity of 3 into 10 raised to power 4 meter per second, accurate up to 0.001% will be. This we have to find, and it is given that students, this is centimeter per second, and h is given as, sorry, h upon 4 pi is given. H upon 4 pi is given as 6.626 into 10 raised to power minus 27 ergs centimeter. Now students, यहाँ पर आप देख लो CGS system use कर रहे हैं, सेंटीमीटर में है, एनर्जी भी ergs में है. So we have to find out uncertainty in position. Now options we have 1.92 centimeter. Then second option we have 7.868 centimeter. Then we have 5.76 centimeter. And then we have 3.84 centimeter. Now students, let's solve this one. Uncertainty in position, delta x we have to determine, m delta v, and it is equal to h upon 4 pi. Now this is the formula. Now students, velocity is given 3 into 10 raised to power 4 centimeter per second. But students, this velocity is accurate up to what? 0.001%. That means there is uncertainty in velocity, और वो कितना है? It is 0.001% of 3 into 10 raised to power 4 centimeter per second. So students, this becomes what? 3 into this is 10 raised to power minus 3, ये भी ऊपर जाएगा, 10 raised to power this is what? 10 raised to power c minus 3, ये यहाँ cancel, 2 हो गया. So this is 10 raised to power 2 centimeter per second, or students ये 2. So we have what? 3.3 centimeter per second. So this is delta v. So students, delta x निकाल सकते हैं. It is h upon 4 pi m into delta v. Now students, h upon 4 pi is given. It is 6.626 into 10 raised to power what? Minus 27. Delta v we know it is 0.3 into, then students we have mass 9.1 into 10 raised to power minus 20. Now since it is in CGA system, so it will be 28. So students, solving this we get, आपका ये cancel, ये 10 ऊपर गया, so we have 66.26 and then we have 9.1 into 0.3. So students, this will be approximately 2, so nearest answer is 1.92. So students, this is the correct answer, so that is option A is correct. Now students, let's solve one more numerical. Now this was asked in AIMS. Students, this question says the uncertainties in the velocities of two particles A and B are 0.05 and 0.02 meter per second respectively. The mass of B is 5 times to that of A. What is the ratio of uncertainties in their position? So that means delta x A upon delta x B हमें निकालना है. So students, we know that, see, delta x into m delta V is equal to h upon 4 pi, or we write delta x is equal to h upon 4 pi m into delta V. Now students, here h 4 pi ये सब constant है, so we say delta x जो है it is proportional, inversely proportional to m into delta V, because बाकी सब constant है. So now students, see, delta x A upon delta x B क्या होगा? Now delta x A, so क्योंकि inverse proportional है, so we write mass of A into uncertainty in velocity of A, and this will be mass of B, uncertainty in velocity of B. But since it is given that mass of B is 5 times to that of A, so MB upon ये 5 हो जाएगा students, because 5m upon m cancel हो जाएगा. Now uncertainty delta V और delta A के given है. Delta V का हो गया, it is 0.02 and that of A is 0.05. So students, this is what? 2 only. So students, uncertainty का जो ratio है of particles A and B, it is found to be 2, which means option A is the correct answer. So students, that is all for today. In next lecture, we will discuss quantum mechanical model of atom. Thank you students.